Okay, so multiplicity is the last thing I got to show you with these graphs. I'm just going to tell you what it is, and then I'll show you how it works. So multiplicity, here's how we're going to think about it. Multiplicity is the power that each factor is raised to. Power that each factor is raised to. So, like, let's look at this one for a quick example. Remember, each of these pieces we consider a factor because it's in factored form. So each one of these pieces is a factor, okay? We talk about the multiplicity of each one of those factors, and it's the power that whatever that factor is raised to. So like this one, x minus 3, is raised to a power of 2. So I would say that this factor has a multiplicity of 2. Does that make a little sense? Each. So this one has a multiplicity of 2. What does this one have? It has a multiplicity of 1. Remember, if you don't see an exponent, it just means there's a 1 there. All right. So that's what it is. Now I'll tell you what it means and what it tells us. Okay. If the multiplicity of a factor is 1, it says meaning there's only one factor for that. 0, we'll talk about that in a little bit. If the multiplicity is 1, like this one right here, that tells you what the graph does at that x-intercept. Because remember, these tell you what the x-intercepts are, right? So this tells you that 1 is an x-intercept. And since the multiplicity of 1, it'll tell you what it does at that x-intercept. So if the multiplicity is 1, do I have enough room for this? If the multiplicity is 1, the graph, we'll just say cross. If the multiplicity is 1, the graph is going to cross the x-axis right there. Every single one we've looked at up to this point has looked like that, okay? But it might be a little bit different sometimes. Let's say the multiplicity is an odd number, but it's not 1. So it's like 3 or 5 or, 31 or something. I don't know. It's an odd number. That means you are going to cross the x-axis with a bend. We're not going to talk about that a ton, but it's good to see it. So we cross with a bend. That one's not super important for us. Really, the only type of multiplicity that we're going to work with other than 1 is if the multiplicity is even. So if it's 2 or 4 or 6 or some even number. And if the multiplicity is even, the graph is going to bounce. The graph is going to bounce at that x-intercept. Okay? I'm going to give you a second to write that down if you're writing it down, and then I'm going to show you what I mean here, because this might not make a ton of sense. Just saying what all this stuff is, it'll make more sense when you see it. Okay? So if you're writing it down, I'll let you finish writing it down, and then I'll show you what I'm talking about. Y'all are so quiet. Really? Yeah. Interesting. All right. So let me give you an example here. So this one right here. End behavior. Everything up until we actually do the graph is going to be exactly the same. All right. So end behavior, you need the leading coefficient and you need the degree. All right. Leading coefficient's positive. So what does that mean? Right side's going up. How do I know it's positive? There's no negative sign in front, so we're good. All right, what's the degree? 2, but be careful. There's 1, there's 2. But remember what x minus 3 squared really means. It really looks like this. X minus 1 x minus 3, and then another x minus 3, right? Because if you square something, that's just multiplying it by itself. So now, if there's an exponent, that counts as 2 x's. So now that you know that, what's the degree? There's 3. There's 1, 2, 3 x's, or you can think about it like this: 1, 2, 3, right? Because the 2 gets an extra one in there. Does that make a little bit of sense? So the degree is 3. Even though you only see 2 x's, there's really 3 in there, okay? All right, so it's an odd number, so what does that mean about the left side? It's got to go down. Odd means they don't match. Football ref doesn't know how to signal touchdown, okay? So there's the end behavior. What are my zeros? 1 and 3. Again, you just flip these. You guys know why we just flip those? We talked about this yesterday a little bit. It's as if you're just taking the factors, setting them equal to 0, and solving them like you normally would if you were solving by factoring. They're just easy to solve because you just flip them. Okay? All right, y-intercept. You guys remember how to find that? What do you do?
Change all the x's to 0.
Yeah. Okay, so let's see what we get here. 0 minus 1 is -1. -3 squared. But hold up, what's -3 squared? +9. So that's -1 times +9, which is -9. So my y-intercept is -9. So you got to be careful if you have an exponent in there. It might change things up a little bit. All right, so now we got all our pieces. Let's go put everything on the graph, just like yesterday. 0's at 1. Oh, boy. I think I get too close to the board. This board is like super sensitive. 1, 3. Y-intercept down here at -9. All right. End behavior, we can put that in. End behavior is, what was it, down, up? So from here down, it's down. From here forward, it's up. Okay. So now here's where the multiplicity comes in, okay? I know that the graph is going to come up to this x-intercept, right? If I'm coming this way, I got to hit the y-intercept, and I know I'm going to come up to 1. That's a bad line, but you know what I'm doing. I know I need to come up to 1. We got to think about what happens at 1, though, and that depends on the multiplicity. I'm getting the 0 of 1 from this factor. What's the multiplicity of that factor? 1, because it's getting raised to the first power, right? That's its exponent. If the multiplicity is 1, that means you cross. So that's just like all the ones we did yesterday. That's just normal. There's nothing funky about that. So I'm going to come up to 1, and I need to cross it, just like normal. So then I know I need to come back down to get 3. Well, yesterday we would have just said, well, we go down to 3 and we cross it. But we got a problem. What's the problem? It doesn't match the end behavior, right? So we got to think about the multiplicity here. I know I need to come down to 3. I'm getting that x-intercept from this factor, and we already talked about how that has a multiplicity of 2, right? Well, if the multiplicity is even, that means you bounce. You don't cross the x-axis. You don't cross the x-axis. You come down, you hit it, and you bounce off of it, right? Does this make a little bit of sense? Which would make this thing work, right? I'm coming down to 3. I'm going to hit it. Oops. I'm going to hit it, and I'm not going to cross it. I'm going to bounce off of it. And now that matches my end behavior. Yeah. Yeah, this graph sucks. Let's clean this graph up. I'm a bad graph drawer. We'll make it look a little bit better. So I know that the end behavior is up, down, so I'm going to come up. I crossed that one. I come hit this one and bounce off of it kind of like a U. Okay? And again, we're not looking for like a perfect picture here, because I have no way of knowing exactly like how high I go or how skinny it is. I don't know that. I just want a general picture of what it looks like. Does that make a little sense? Okay. All right. Why don't you guys try... Why don't you try one of those, 7 or 8, whichever one you want. Everything is the same. End behavior is the same. 0 is the same. Y-intercept is the same. Putting all the points on there is the same. It's just different once you draw the graph, because now you need to ask yourself, do I cross at that x-intercept or do I bounce off of it? All right. So give one of those a try. We got to find end behavior. So leading coefficient, what is it? Positive or negative? Positive, so that means the right side's going up. What's the degree? 4, but wait a minute, I only see 3 x's. One of them is squared, so that counts as 2. So there's 1, 2, 3, 4. That's an even number. What does that mean? Left side has to match. There's the end behavior. Zeros are 1, 3, 4. Y-intercept, you plug in 0. What do you get for the y-intercept? 36. Big number. That's fine. 36. So let's get our stuff down there. I got 1, 3, 4. The y-intercept is like up on the ceiling, so I'm not going to draw it, but just know it's way up there. Okay. End behavior's up, up. So I'm doing this. Here's where the multiplicity comes in. At 1, I need to decide if I cross or bounce. What do you think I do? Cross. Why? Because this factor is raised to the first power, right? And if it's raised to the first power, you just cross it. All right, then I go over to 3. What's happening at 3? Cross or bounce? Bounce. Why is that? Because the multiplicity of that factor is 2. That's even, so I got to come up to 3, touch it, bounce off of it. All right, and then 4 is the same as 1. It's raised to the first power, so I got to cross it. There it is. And it matches my end behavior. So if you think you're doing something at the end and it's not matching your end behavior, like if you're trying to cross it but it's bouncing, there's got to be something up there, right? There must be something wrong. Either your end behavior is wrong or your multiplicity is wrong or something. Is this making a little bit of sense? Okay. All right, I have one more type of problem to show you, and then you guys are going to do a Sifu, okay? Let's do this one. All right, it says we want to use this graph. Oh gosh, sorry. You're gonna kill me one of these days, man. I'm gonna like crack my head open on that table. Basically, this is going backwards. This time I'm given the graph, and I want to say some stuff about it. Okay. So you have all the skills to answer this question. Like you have every piece of knowledge you need to answer this question. We're just applying that knowledge in a different way. All right. And that's kind of what math is all about. So leading coefficient, it asks me, is the leading coefficient positive or negative? Well, just looking at that graph, what do you think it is? Negative. How do you know? Because the right side's going down. So that means that the leading coefficient must be negative because the right side's going down. What about the degree? Is it odd or even? How do you know? Because the sides match, and that must mean that the degree is even. You know, I don't have the function, but I can still answer these questions just because I know what's happening on the graph. I can say something intelligent about what's going on. All right, now let's think about domain and range. We haven't talked about this in a little bit. What's the domain here? It's all the real numbers. Those are all the x values where my function exists. It doesn't stop in either direction. So the domain is all the real numbers, okay? The range. Now we're looking at y. So remember, when we talk about range, we're asking ourselves, is there a place where the graph gets cut off going up and down? Well, does it stop? Yeah, where does it stop? Something, I don't know exactly. 1 point something. We'll say it's 1.25. We're not going to be perfectly exact, but we can say it's somewhere in there. Okay? That's where it gets cut off. So how do you write the range? Y is less than or equal to, because you need to be beneath that. 1.25. Cool. There's a domain and range. Now we got to talk increasing and decreasing. So remember, increasing and decreasing is reading left to right. Pretend like it's a roller coaster. Roller coaster's moving this way, and here's us on our roller coaster car. Can you tell what that is? Kind of. It's a roller coaster car, okay? And there's 2 people in it. I wish there was more, but whatever. So we're going up the roller coaster. What's happening here? Am I increasing or decreasing? I'm increasing. You guys ever ridden a roller coaster before? Yes. Okay, so you get up to the top and you're about to freak out. Well, you're increasing there. Where do you stop increasing? You don't see, how can you not know that that's a roller coaster? Which one? Oh. I've been on that one. The rock and roller coaster. Do you think I should pause the video? I wonder if people can hear this. Hey, video people.
There's one in Dollywood in Tennessee that goes at like a 95-degree angle and then drops you right back down.
There's one that goes 90 degrees down. It's the one in SeaWorld.
Well, I'll tell you what, though. None of those are as intense as this one.
Definitely
Definitely not.
not.
On the x-axis, where on the x-axis do you get up to the top and you're about to start going down?
The 1.25.
Negative 1, I don't know, negative 1.5? Somewhere in there?
Definitely not negative 1.
No, definitely not negative 1.
Like negative 1.5.
Let's just say negative 1.5. Okay? So we got to write that as an inequality. Are you increasing to the right or to the left of negative 1.5?
To the left.
To the left. All right, so how would I write that? It's all of the x's that are what? Am I less than or greater than negative 1.5? I'm less than. What about, should I say equal to?
Yeah.
What's happening exactly at negative 1.5? You're like going up and up and up and up and up and up, and then you get to the top and you're like, oh my gosh. All right, and you're looking down. So you're not actually going up anymore. That's when you have the moment of, I shouldn't have gotten on this roller coaster, right? So it's x is less than negative 1.5. That's where we're increasing. And then everything gets crazy. You're up at the top here. You're obviously not standing. Hopefully you're not standing. But this is what you're doing up at the top. And then you're like, oh my gosh. I lost him. Hey, how do you write this? X is greater than negative 1.5. Once you get past 1.5, you're going down the roller coaster and peeing your pants.
Yeah.
Okay? No.
You did not.
No, I did not. I did not pee my pants.